Welcome to The Explainer. Today, we're going to get our hands dirty and look under the hood of a really unique adventure game engine. It basically throws out the old, rigid guess-the-verb parsers from classic games and swaps them out for something way more modern, an approach that's borrowed directly from the world of search engines. Let's dig in and see how it all works.
So the entire design really comes down to this one simple but powerful question. You know how old text adventures made you guess the exact command, like get lamp? Well, this engine just flips that whole idea on its head. Instead of trying to make your input match a list of predefined commands, it treats whatever you type as a search query and runs it against a dynamic list of every single thing you can do right now.
All right, so how does that search even work? Well, before you can search for something, you need a database, an index to search through, right? So before you even get a chance to type, the engine quickly scans the entire game world to build a complete, up-to-the-second picture of every possible action you can take in that moment.
And here's the secret sauce, the just-in-time action corpus. The most important words, they are just in time. See, this isn't some giant static list of every command in the whole game. No way! Instead, after every single turn, the engine completely throws out the old list and builds a brand new one from scratch. It's always perfectly in sync with your current location, what's in your inventory, and everything around you.
Now, this whole process is handled by a function called _build_JIT_actions, and it's just brilliantly systematic. First, it reads the game's current reality from a JSON file. Then it just walks through all the possibilities, step by step. It generates movement commands based on the exits it sees. It creates actions like take or drop for every item in view. It checks for special rules, like if you can turn a lantern on or off. It literally harvests everything, compiling it all into a complete catalog of what's possible right here, right now.
And this is where it gets really, really clever. The engine doesn't just generate one phrase for each action. No. For every single thing you can do, like turning on a lantern, it automatically generates a whole list of natural language variants. You've got functions in the code like _toggle phrase variants that are busy creating phrases like turn on lantern on, switch on the lantern, you name it. It does this for everything, automatically, which means the player gets this super forgiving and intuitive experience, and the developer didn't have to sit there and manually type in every possible synonym. Okay, so the engine has built its haystack, this huge temporary list of every possible action and all the ways you could phrase it. Now comes the hard part, finding the needle. How does it take the player's messy human input and match it to the one single correct action in that giant list? Well, the first thing it does is it expands your query. It doesn't just search for check lantern. The engine does something really smart. It looks at that action corpus it just built. If it sees that inspect lantern and examine lantern are also possible right now, it learns that in this context, inspect and examine are basically synonyms for check. So it adds those words to your search, which casts a much, much wider net to find what you really mean. Now, at the very heart of this matching process is an algorithm called BM25. This is a classic, really powerful function that comes straight out of the world of information retrieval. You know, think about the early days of search engines. It's designed to rank documents based on how relevant they are to a query. In our case, every possible action phrase is a document, and what you typed is the query. BM25 is amazing at figuring out the best match, especially rewarding phrases that use important but less common words.
But the system isn't just a one-trick pony. It doesn't rely only on BM25. It actually uses a weighted combination of scores to find the absolute best match. As you can see, an exact match of words gets the highest priority. That makes sense. After that, it looks at those expanded synonyms we just talked about. And finally, that lexical BM25 score comes in to handle the fuzzy stuff and break any ties. It's a really pragmatic approach that values a direct hit above all else.
So what happens when a command is genuinely ambiguous? What if you type something that could mean two different things? Well, to avoid making a mistake, the engine uses a confidence margin. It won't just blindly pick the action with the highest score. It will only execute that action if its score beats the next best option by at least 0.06. If the race is too close to call, the engine just plays it safe and asks you for clarification. It's a simple but crucial guardrail to prevent it from doing the wrong thing. Okay, let's recap. The engine has built its context, it's taken your input, and it has picked a single, high-confidence action. The final piece of the puzzle is, well, making something actually happen in the game world.
And this, for me, is where the design's elegance really just shines through. The action that gets chosen doesn't call some big, complicated, hard-coded function. Nope. Instead, it just contains a list of these simple, human-readable effect strings. This string right here isn't code, it's data. It's a simple instruction that says, add the secret map to the player's inventory.
So there's this other function called _apply_effect that acts as the interpreter for these strings. It parses that simple command, it navigates the JSON data structure, which represents the entire game world, and it applies that change directly. It's a simple, totally predictable, and incredibly powerful way to manage the game's state. There's one single source of truth, that JSON file, and these little effect strings are the only things that are allowed to change it.
What this all creates is a true data-driven state machine. Now that might sound like a fancy term, but the idea is actually really simple. The actual game logic, what happens when you pick up a key or talk to a character, it lives entirely in the JSON data, not in the Python code. This creates this perfect, clean separation between the engine and the content, which means you could write a totally new adventure game without ever touching a single line of the engine's code.
So, now that we've walked through this whole pipeline, from context to intent to consequence, what's the big idea here? What's the crucial point we should take away from this really elegant design?
It really all boils down to these core principles. The logic is decoupled, which means the engine and the game story can evolve totally independently. The behavior is data-driven, which makes it incredibly flexible and easy for designers to build on. There is no rigid parser, which makes for a much more natural and fun player experience. And finally, the context is always state-aware, rebuilt just in time, which guarantees the engine's understanding of the world is always perfectly current. This powerful pattern of treating user input as a search query against a dynamically generated set of possible actions, that goes so far beyond just text adventures. And it leaves us with a final thought. Where else could we apply this approach? Think about complex configuration tools or chatbots, or really any system that currently relies on users knowing a strict set of commands. What could you build if you just replaced that rigid parser with a small, context-aware search engine?